Hello there. We are in the center table up front, nice and close and personal to Mr. Vermani in class. What we do in our statistics project was we did our Stroop test, and unlike various other groups that did this, we decided to introduce a new element, the camera. As other research has documented, camera can affect people's performance in various ways, such as doing a test. It adds the pressure of knowing that all your mistakes will be shown on the internet for everyone's viewing pleasure. And we are going to run through our setup.
In our experiment, we asked individuals in the library to come into a group study room to do the Stroop test. Well, there was only one subject in the room. One of us was timing, and the other three were checking for errors.
Here we have one of the nice library quiet rooms, and even though it is quite quiet in here, we can assure you that there's plenty of clamor outside. Our sample pool was the conveniently located pardons of the library who we would pool into the room and test them on a simple Stroop test of about 20 words.
To randomize the process, we use this handy little app where you flip a coin. If it landed heads, the subject would not receive a camera, and if it flipped tails, the subject would receive a camera. This is
A reenactment
of what would happen if you were to be a subject as part of our experiment. First, you would come into the isolation room, sit down, close the door behind you, get all nice and cozy, and then I would tell you the following instructions that you are about to partake in a Stroop test. What is going to happen is you will see words and colors that do not match. For example, you will see the word green, but it will be color blue, and I want you just to say blue. You'll try and go as fast as you can without losing accuracy. You will be filmed throughout this process. However, your face will not be seen. At this point, if you wish to not partake in this experiment, you are allowed to leave. You can begin on your mark. Ready?
green, yellow, red, green.
Thank you for participating.
So once we finished gathering all our data, we analyzed it by comparing the average completion times and the average amount of errors made for 3 categories: ages from 15 through 18, and boys versus girls, and camera versus no camera. Now, a possible explanation for these occurrences were that the younger subjects felt like this was really a test and took it more seriously, thus they took more time and made less errors. For older subjects, they felt like this was something they needed to get through really quickly, so they completed it at a faster pace, but with more errors. Okay, so for boys versus girls, there doesn't seem to be a significant difference between the average completion times and the average amount of errors made for boys versus girls. Lastly, for camera versus no camera, it seems like that the camera presence affected our subjects. Because they could have been more nervous, they went through the test quicker, but as a consequence made more errors. Next, we'll see what the statistics say about the assumptions made from these graphs.
After we collected our data, we decided that we should run a 2-sample t-test for the difference of time between people with camera present for the Stroop test and people without camera. So of course, we followed normal statistic protocol. The null hypothesis was that there was no difference in average Stroop test completion times for those individuals being filmed and those not being filmed. And our alternative hypothesis, of course, was that there would be a difference between the time for people taking the Stroop test with a camera present and without a camera present. Next, of course, we had to make sure that our conditions were met. An SRS was conducted on whether or not the subjects received a camera or not. It was obviously independent as there are more than 300 people at gun, which n is greater than 10n. And of course we could use normality because we had 30 subjects in our sample, which meant we could use the central limit theorem. 30 is greater than or equal to 30 in case you didn't know. And for our calculations, we found out that this test statistic was negative 0.190. 7271577. which meant that the p-value was 0.805. So unfortunately, because the p-value was larger than alpha, we didn't have statistically significant evidence to reject HO. Therefore, we concluded that there was no difference in time between camera and no camera. We then decided to look at the data another way by conducting a 2-sample t-interval for the time completion, just to make sure that we weren't incompetent the first time that we analyzed the data. Obviously, the conditions were the same, and we found that the confidence interval ranged from -4.305 to 3.5716, and we're 95% confident about this. Unfortunately, since 0 was in our confidence interval, again, we have to conclude that the difference in the true mean correlation times between subjects with a camera and without are the same, and we're wrong.
We also did a test, 2-sample t-test for mistakes. The hypothesis, HO, was there is no difference in Stroop test mistakes for those being filmed and those that aren't being filmed. The HA was, of course, there is a difference in average test mistakes in the Stroop test for those being filmed and that aren't being filmed. The conditions are the same as what Jonah said earlier. When we calculated the test statistic, our t-value was 1.87552337. Our p-value was 0.071509381119. Since our p-value 0.0715093819 is larger than alpha, 0.05, we do not have statistically significant evidence to reject HO. Therefore, we fail to conclude that there's a difference in the average Stroop test mistakes for those being filmed and those that are not being filmed. We also made a 2-sample t-interval for mistakes. The conditions are the same. And when we constructed our 95% confidence interval, we got -0.0625 and 1.3958. Therefore, we are 95% confident that the true mean difference in mistakes lies within -0.0625 and 1.3958. Since zero is included in our confidence interval, we can conclude that there is no difference in the true mean mistakes between camera and no camera. Darn, wrong again! A possible error in our procedure was that there were many people in the room at the time when we were testing, and so we thought that maybe there would be some problem with concentration when the noise level was kind of loud. Another possible error is that we told the subjects that we weren't going to show their faces, and maybe they got a little less nervous because they knew that they weren't going to be filmed in the face.
Sorry.
We also may have experienced an undercoverage bias for the individuals who didn't want to take the test because they were too shy and we gave them the opportunity to leave. We also may have experienced a bias when we selected individuals who we were familiar with, and they may have felt less nervous when taking the test even in front of a camera.
Hey, what's up, Lynn?
Hi, Cookie.
Hey, do you want to take a test with me?
All right,
Let's go.
We conclude that there is no significant difference between the average completion times and the average amount of errors made with the camera present and without the camera present.